Okay, that was Sisters High School in Sisters, Oregon. Now we're going to move all the way across the United States to the eastern seaboard to the New England area. And we're going to talk about IYRS School of Technology and Trades. Now, what does IYRS stand for? Well, it stands for the International Yacht Restoration School, and that's in Newport, Rhode Island. And this is a pretty nice, cool case study here. Now, what do? IYRS is a nonprofit post-secondary experimental learning school in Newport, Rhode Island. The school offers education and training in shipbuilding, restoration, composites, marine systems, digital modeling, and fabrication. And Kelsey Britton is the program manager and instructor for the composites program. The first year in this program, the students build a complete BeetleCat sailboat. I'm going to show you that in a minute. So actually, they make a sailboat from scratch to sailing in the first year. In the second year, they come back and they refurbish the BeetleCat sailboat that they manufactured the previous year. So the boat has been in dry dock for a year, and then they come back and they learned boat building restoration techniques. A little bit about Kelsey. Kelsey, she is actually an IYRS graduate. She initially graduated and did some other things in other industries, but she was always brought back home and loved the boat building industry. And she was actually offered a teaching position at IYRS because she excelled so greatly in the program. And you could say that boating and sailing is in her family's blood. She was taught how to sail by her mother when she was just a young girl. Her brother is a ferry boat captain in New London, Connecticut, and her father is a marine mechanic and manager there in Newport, Rhode Island. And also, Kelsey mentioned here, we sat down with her and had a long discussion interview with her. And she mentions that she uses our articles on the MecSoft's Tech blog actually to teach her students how to be proficient in RhinoCAM. So that's pretty cool. As I mentioned, the first year students, they actually design and build their own sailboat. And on the top two images, you see students actually on the drawing boards designing a BeetleCat sailboat. And that's primarily the reason why they use Rhino, because Rhino CAD modeling is so proficiently used in the boat building industry. And down below, you see two examples of some BeetleCat sailboats that were designed and built by students and then sailed at the end of their first year. Now, why am I looking at a bicycle helmet? Well, at the end of the program, students can choose any project they want to be their end of year program, and it's going to count for a large part of their grade. So we're talking about the Composites Technology program, where where RhinoCAM is used proficiently in the composites class. So student Wyatt Jeffries is an avid bicyclist, so he wanted to design his own and manufacture his own bicycle helmet. So on the right here, you see the RhinoCAM part of the helmet, and we're going to be taking a look at this RhinoCAM part file in just a second. On the left there, you see the helmet, and on the right, you see Wyatt holding the end product. So this is a composite manufactured bicycle helmet from fiberglass. Now here we're looking at the helmet design in Rhino. So you have a number of views of the helmet. You have an outer shell, and then you have holes in the top, and then you have it trimmed, at the bottom. And you see that it's outfitted with foam inserts on the inside of the helmet. Now, how is this done in RhinoCAM? Well, for Composites Technology, you may be familiar with composites in that it is a combination of resins and material that's mixed or laid in with the resin to harden. And in this case, the composite material is fiberglass. So what you need is a cavity in order to lay up the fiberglass composite material. So Wyatt designed 2 cavity blocks, right and left. If you look at the top left image here, you see the left side cavity block, and if you see it represents 1/2 of the helmet outer shell. So this is a negative cavity of the outer shell of the bicycle helmet. And then also you can see the trim line, the area where the composite will be trimmed after it's pulled out of the mold. So on the top right, we see the initial 2.5 axis facing operation and Z-level finishing to clear out the locator pin holes. And then in the bottom, where the action takes place on the bottom left, you see a Z-level roughing operation, or horizontal roughing, or so it's called, and it's done with a 12.7 1/2 inch diameter flat end mill to clear out the stock for the cavity. And then over here on the bottom right, we see 2 finishing operations. We have an initial Z-level finishing operation that gets a good finish on the sidewalls, and another operation of parallel finishing to get a good finish in the bottom area. And that's done with a 6.35 millimeter diameter ball mill. And we're going to be taking a look at this part here in just a second. So here on the left, we see Wyatt tending to his cavity molds. They're made out of 6 layers of MDF material, each side cavity. And what he's doing, he's preparing it for composite layup. So after it's machined out, he sands it, and then he polishes it, coats it in resin and then polishes it, and then sands it some more and gets it ready for the composite layup. On this slide, on the left, you see the bicycle helmet after it's been laid up with the fiberglass composite material. So that's it's coated in resin, and the materials fit into the cavity to form the outer shell of the bicycle helmet. And on the right, you see Wyatt again showing off his end result. Now, one thing else that I want to point out here too, the foam inserts, they use the same cavity mold for machining the foam insert. So they filled it with the foam, and then they machined out, a thickness 10, I think it's 10 millimeters thick from the outer shell offset, and then machined that out, and then fitted that foam insert into the helmet. Now, here again, we asked Kelsey, why RhinoCAM? Why aren't you using something else? And the main reason here, obviously, is that they're using Rhino for their boat building and composites class. And obviously, RhinoCAM is the obvious choice to run CAM inside of Rhino. The main obvious reasons is that it runs completely inside of Rhino. You don't need 2 different programs. You're not translating any part files from one program to another that can introduce errors. And your CAM files, your CAM program toolpaths are contained right in the Rhino part file. So you save the Rhino file, you load RhinoCAM, and your CAM toolpaths are right there. So you make a change in the Rhino part, obviously it propagates to the toolpath. So that's the primary reason. And this is pretty cool here as well, and I wanted to tell you about this. On the left, you see IYRS alumni, and they're participating in the restoration of the Mayflower II. Now, in the 1950s, they built a full-size, full working replica of the Mayflower, and they dubbed it the Mayflower II. So in, I believe this was in 2015, I believe, they actually did a complete restoration of the Mayflower II, and IYRS alumni joined them in that effort at the Mystic Seaport in Mystic, Connecticut. And on the right, you see the Mayflower II being towed out of the Newport port to begin its sailing journey around the world. That's pretty cool. And also, there's a link here if you want to look at. There's a video that talks about this whole restoration program and the IYRS alumni, how they participated in it. And I'll put this link actually in the description in the webinar replay, and you can link to it directly from there. Okay, if you want some more information about IYRS, School of Technology and Trades in Newport, Rhode Island, you can visit them online at iyrs.edu, and you can learn all about their program, the different classes, and you can sign up for classes, everything you could do directly from that website. And then on the right, if you want more information about RhinoCAM, you can go to our RhinoCAM product page, MecSoft.com/RhinoCAM. So again, if anybody has any questions about these projects we're looking at, please put them in the chat window, and Joe will get them questions, or he'll get them answered, or he'll alert me, and we'll talk about them. Okay, here's the cool part. We're going to look at the actual student project parts inside of both Visual CAD/CAM and RhinoCAM. So let's take a look at Sisters High School first. Okay, I hope y'all can see that. This is the left side cavity mold for Wyatt's bicycle helmet, and I have the bicycle helmet actual part actually shown here, so you can see that as well with the mesh wiring turned on. So this is the bicycle helmet. Now from that helmet, Wyatt designed a cavity. So there's two sides to this cavity. You have locator pins up here where the two sides line up to mount together, and then you have the actual cavity, left side cavity of the outer shell here in Rhino. So let's take a look at the toolpaths. So initially we have a 2.5 axis facing operation that just uses the bottom perimeter as a containment area, and it clears off the top of the mold flush. And then we have a horizontal finishing that clears out the 4 locator pins. These are not through holes, these are actual full radius pin holes there. And then for the initial horizontal roughing operation, this is Z-level roughing and levels. So let's take a look at this. You can just get a good look there of the Z-levels. So this is Z-level roughing just to hog out all this material out and prepare it for finishing. So for finishing, initially we have a horizontal finishing operation again, and this is Z-level finishing, where it slices the part in XY planes in different depths in the Z-axis. So you have a nice step over here, but down in here the step overs get further and further apart, which leave cusping. And then for this particular part, I wanted to show you a combination of both. Rather than doing the optimized XY machining, I wanted to show you how you can use another operation in combination with the Z-level finishing to get a good finish on this part. So this is a Z-level finishing. The next operation is a parallel finishing along the same area. So in parallel finishing, the toolpath follows a straight line along either the X or the Y or whatever angle you tell it to follow. In this case, it's following along the X-axis, and it's just cleaning up, finishing this area, mostly in the bottom section here where it's got a lot of cusping left. So let's take a look at the cut material simulation for this. So let's go to the setup. So this is our box stock. Initially, we're going to clear the top off. Let's turn the toolpath off so you can see this a little bit better. So this is our 2.5 axis facing, just to flush the top off. And then here is our horizontal finishing to clear out the 4 locator holes. And then we have our horizontal roughing to hog out the material of the cavity. Now this is the initial horizontal finishing or Z-level finishing in that same cavity. And you see that very good coverage up in the near vertical areas, okay, where the cut levels are spaced closest together. So if you give it a step down distance, that step down distance is going to be realized in the near vertical areas. So as it gets down closer to the horizontal areas, you start seeing the cusping going on. And typically in finishing, you would use a combination of 2 finishing operations, one to go one way and then one to go the opposite way to clean up that cavity. In the first operation, we're doing a horizontal finishing, and the second one, we're doing a parallel finishing. And you see how nice. Yes.
There was a question on where do you turn on the optimized XY machining?
Okay.
And I actually posted a link to the blog article.
Okay.
On Sisters Wear, but if you can quickly show it.
Yeah, let's go back to the Sisters High School one, and I'll show it to you there. Okay, so this is the ukulele neck, and let's go into the first horizontal finishing or Z-level finishing operation without optimized XY machining enabled. And this one has it enabled. So let's go into the toolpath dialog here. So for horizontal finishing, here's all your control parameter tabs. There's a tab called Optimize Machining, and you select that tab, and there's a checkbox right here to turn it on and off. So initially, you just turn it on, and you can provide it with additional parameters to control the step over that it's going to add in those areas. So here it's 0.03 or 30 thousandths step over, and you can also control the entry and exit, in the additional step over areas. So that's where it's enabled in the horizontal finishing dialog. Okay, hope I answered that. If not, we can get some more. As Joe mentioned, he put a link in the chat session to our blog post that talks about that specifically. Okay, let's go back over to RhinoCAM for a second. So we talked about that, and in this particular, we didn't use the optimized XY machining. We wanted to show you how you can combine 2 operations to get really good coverage in a cavity area.